Electronics practice, power supplies troubleshooting. Introductions. Troubleshootings in any equipment in a circuit involves the following activities: to identify the exact nature of the problem, to identify the section causing the problem, to isolate and arrive at the exact causes, to confirm the causes by necessary test, to replace the problem causes parts, to reset and confirm the satisfactory working. The following are the general steps involved in the troubleshooting: to confirm the causes by necessary tools, to replace the problem causing parts, to reset and confirm the satisfactory working. The following are the general steps involved in troubleshooting: physical physical and sensory test. Physical and sensory test. Look for the most common physical faults such as broken wires, cracked circuit boards, dry solders, and burnt out components. Smell for hot या burning components. Feel with the fingers for unduly hot component. Champion's diagnosis. Learn the operation of the system to be repaired with help of its block diagram and its input and output specifications. Observe the symptoms produced by the defective system and determine which section or function would produce the symptoms. Testing and replacing defective components. When the probable defective section has been diagnosed, check the problem components in that section of the circuit that are most likely to go defective in the order given below. Components should be checked in the order given below because that is the order in which they fall in most cases. Active high power component, for example, components such as transistor, IC, and diodes, high power devices are physically large in size and are used for handling the high power generally in output circuits. Active power component, these are the same as in but are the physical small and can handle smaller amounts of the power. High voltage or power passive component, such components are resistor, capacitor, transformer, coil, etc., which handle large amount of the voltage or power. They are found in power supply and output circuits. Low power passive components, these are the same in C but are physically smaller and handle comparatively less power and are low in value ohm, microfarad and microhenry. Note, this produce may not turn out to be turn always, hence do not attempt to replace common sense and meter measurements with the producer. While troubleshooting any electronic system, two main methods are generally adopted. They are step-by-step methods of troubleshooting. This approach is preferred by beginners. In this approach, the problem causing part or section is identified by testing the parts of section from the beginning to the end as shown pictures 1. Given below, this is the voltage transformer and this is rectification and this is smoothing circuit and a troubleshooting sequence step by step approach. Although this approach may take more time, this is the most suited approach for the beginners. Shortcut या logical approach method of troubleshooting. This method is used by experienced servicing people in the method the problem choosing part section is identified from the nature of the problem symptoms. Divide and conjugate procedures is the adopt to arrive at the exact cues. This methods takes less time comparatively. Troubleshooting power supply. All electronic system can be broken down into blocks generally based on their function. Pictures 1 shown the various blocks of a simple power supply. Each block has a particular function of to problem to perform particular function to perform. Before carrying out troubleshooting of power supply, the first things to be done is to isolate the load connected to the power supply. This is because the connected load itself may be the cause of the problem as shown in the problem tree PT. This is the defective component in the power supply, and this is defective load connected, and this is the problems causes defective and defective power supply, and meanings A and B resulting in C. Once it performed that power supply has the same defect even with load disconnect. You can follow either the step-by-step approach or the logical approach to troubleshoot the power supply. Step-by-step approach to troubleshoot power supply. In the step-by-step approach of troubleshooting, the various block of the power supply is pictures 1 and the components of the block are checked one by one, starting with blocks 1 and step as given below. Step 1. Confirm the presence and satisfactory level of the means supply from which the power supply is powered. Step 2. Switch the power on and test and note down exact nature of the problem. Although the nature of the problem has been already told, it is essential to confirm the exact nature of the problem. This is because in a real life situation, the customer may not be technical person informed the exact nature of the problem. Step 3. The carry out physical and sensor test. Step 4. Trace the circuit, identify and wrong polarity connection. Step 5. Remove the power cord of power supply from the mains and test the power cord. Step 6. Test the transformer. And step 7. Test the diodes of the rectifier section. The flow-in form to top button rectangular blocks indicates work to done, action to be taken. Follow the path of the arrow. Diamond blocks indicate a decision to taken after conducting a test making a measurement. If the answer to the question in the diamond blocks is yes, follow the path of yes, continue. If the answer is no, follow the path of no and continue. Rounded rectangular blocks indicates the end of the job. Low output voltage increased, a ripple in output. Here note that two defects are combined, the reason being that these two defects generally occur. Similarly, if the voltage is low, the cues for the also result increase, ripple and vice versa of the course with one exception. That if the mains level itself low of if the secondary voltage of the transformer itself is low due to shorted winding, a low voltage is not associated with increased ripple. The cues for this defect are given problem PT2 in chart 3. Chart 4 shows the service flow diagram FS2 for serving the defective. Note the SFS PT for a full wave rectifier with capacitance filter is almost similar to that of bridge rectifier. However, it is suggested that the trainees shall make SFS PT for full wave rectifier power supply on their own for practice and better understanding of the method.